So because I'm a new scientist, I just wanted to give a quick overview of what our research program is about. Most of our research is based on cropping systems and cropping system diversity with a focus on weed management. So we look at things including diverse crops in our crop rotations, so cereals, oilseeds, pulses, as well as forages. Looking at strategies to increase the competitive ability of crops with weeds, as well as research on herbicide-resistant management and improving soil health, as well as potential new crop opportunities for southern Alberta. So today I'm going to talk about a few main things. I'm just going to give a general overview of the status of herbicide resistance in Western Canada. I'm going to focus in a bit more on glyphosate or Roundup resistance and talk about some potential alternative or adoption of alternative weed management techniques, as well as some new prospects that we're looking at. So to jump right into it, in Canada, we're now sitting at 65 unique herbicide resistance cases, and you can see that that number has increased since about 1985, pretty linearly. And so if we're looking at throughout the world, we're actually sitting at the country with the third most resistant cases, behind the United States and Australia. So those herbicide resistance cases are generally distributed quite evenly throughout the three prairie provinces. However, if you take into consideration the seeded acreage in these provinces, the resistance cases in Manitoba are a bit more dense compared with the other provinces like Alberta and Saskatchewan. And over the past 10 years, Julia Leeson, a research biologist from Saskatoon with Ag Canada, has been conducting a general weeds survey across Western Canada, and over 10 years, or about 10 years, they've looked at almost 6,000 fields, or surveyed 6,000 fields, and those are indicated by the red dots. So from that survey, actually the most recent survey was in Alberta, and I think they measured they looked at about 1,200 fields in Alberta just this past summer. So she's compiled all this data into kind of in a general weed abundance ranking. So weed abundance takes into consideration the frequency of appearance of weed species in fields, as well as the uniformity of weeds in fields and the density of those weeds in fields. And it just ranks weed species from the most to least abundant. So if you look on the far side under the column 2010, I just have the weeds ranked from the most abundant weed in the prairies to the 10th most abundant weed in the prairies currently. And the shade of green on this graph actually shows, or it indicates the abundance. So a darker shade of green would be a more abundant ranking. And you can see the top three weeds in Western Canada have generally remained the same in the last 3 years. So green foxtail, wild oats, wild buckwheat. However, there are some other weeds that have increased in relative abundance since the 1970s, mainly being volunteer canola, as well as false cleavers and spiny annual sow thistle. So the question is, how many of these weeds, or how many of the top 10 weeds do you think are resistant to herbicides? Does anyone have a guess? Seven of them. So in the graph there, we have the herbicide-resistant weeds highlighted in red, and the numbers in brackets beside each weed species. The red numbers indicate herbicide-resistant biotypes in Alberta, and the blue numbers indicate herbicide-resistant biotypes outside of Alberta in the prairies. So immediately, if you look at wild oats, we now have wild oats that are different populations of wild oats that are resistant to 6 different herbicide modes of action. And most recently, we've seen group 14s and 15s resistance in Manitoba. There are also other herbicide-resistant weed species in the prairies. So there's another 14 weed species that are currently resistant, and you can see that a large number of these species are resistant to Group 2 herbicides. And the other thing that I wanted to point out on this slide, kochia is not in the top 10 in Western Canada. However, it is more abundant in this area. And in Saskatchewan, we now have populations that are resistant, or almost all populations in Western Canada are resistant to Group 2s. But we have populations that are now resistant to 2s and 4s, as well as other populations that are 2s and 9s. So we do have a real potential for seeing a triple resistant kochia biotype showing up here in the near future, although it has not yet been found. So the reason why some of these weed species there's a greater number of weed species resistant to Groups 1s and 2s herbicides are because these herbicides have different selection pressures for selecting for mutations that result in herbicide resistance. So here we have just a ranking of the different herbicide groups. So you can see there's a high selection pressure from Group 1s and 2s, which are mainly used in cereal crops, and going down to some of the herbicide groups that are less selective for resistance, such as Group 9s or glyphosate. So this creates a problem, and I'm just going to use wild oats as an example here. So if we look at the crop protection guide, I just pulled out the herbicides that are in the guide for managing wild oats and wheat. And you can see there's quite a few options, but most of them consist of Group 1s and Group 2s. But if we do have a wild oat population that has blanket resistance to Group 1s and Group 2s, which is showing up more and more often these days, you can see that that actually eliminates almost all of your post-emergence herbicides. So we're starting to look at really our only option for managing some of these populations are using pre-emergence herbicides of different groups or alternative methods of weed control. So along with the weed survey in Saskatchewan, they also sent out a grower questionnaire to try and get a handle on the different weed management practices that farmers are currently adopting. So as you can see here, we have these 10 different weed management practices ranked, and the most adopted weed management practice is scouting before in-crop herbicide treatment, followed by a post-emergence herbicide application, herbicide treatments overall, and crop rotation. And continuing on down the list, we have scouting before pre-emergence application, as well as tank mixing herbicides, scouting before fall application, rotating herbicide modes of action, pre-emergence herbicide treatment, followed by scouting again. So this does give us a little bit of reassurance, showing that farmers are they're diversifying their weed management portfolio to try and get a handle on managing some of these herbicide-resistant weeds. So they're including herbicide applications throughout weed life cycles rather than just focusing on a post-emergence application. They're also looking at other methods like tank mixing or rotating herbicide modes of action. So another interesting thing from this questionnaire was that we found a significant difference between farmers that knew that they had herbicide-resistant weeds in their field versus those that didn't. So in black here, you can see the black are the farmers that had herbicide-resistant weeds in their field. And you can see that there's a fairly large difference or an increase in adoption of crop rotation, herbicide group rotation, as well as tank mixing and using pre-emergence herbicides for farmers that knew that they had herbicide-resistant weeds. So farmers are having to adopt some of these alternative practices to try and manage some of these herbicide-resistant weeds. In addition to that, other factors that they found increased with farmers that had herbicide-resistant weeds were growing more competitive crops, as well as increasing crop seeding rates to try and increase the competitive ability of crops with weeds. So just to change gears here for a second, I wanted to bring up this graph. This is the cases of glyphosate or Roundup resistant weeds worldwide. And you can see in the last 2 decades, we've now accumulated 35 different species that are resistant to glyphosate. And that is having some problems, especially with predominantly glyphosate-resistant cropping systems in the US. Here, this is just a picture showing glyphosate-resistant giant ragweed in corn. And you can see the green part above the corn there is actually the giant ragweed. It's not trees. So you can imagine what kind of damage this would do to their yield. So in the US, there's 17 species now that are resistant to glyphosate. Some of the more common, or some of the more recent species being common sunflower as well as Russian thistle. And one thing that I wanted to point out with this slide, the years there are the years that these species were first discovered to be resistant to glyphosate. And all of the species that are resistant to glyphosate in Canada were actually resistant to glyphosate in the US first. So those species are horseweed, or otherwise known as Canada fleabane, giant ragweed, which we just saw in the previous picture, common ragweed, and tall water hemp. So those species are, right now, are more limited to eastern Canada, predominantly in Ontario. And you can see that they've all shown up since about 2008. And in Western Canada, we have, as I'm sure many of you know, we have glyphosate-resistant kochia, which was the first populations were found here in southern Alberta, just south of Lethbridge. So this is just showing the populations that were confirmed in 2012. You can see of glyphosate-resistant kochia. You can see that, I guess the picture's not showing up there, but you can see that the populations kind of range from around the Milk River area all the way up to around Rosetown in Saskatchewan. And actually, Hugh Becky, a research scientist from Ag Canada in Saskatoon, has this past fall completed the herbicide or the glyphosate-resistant post-harvest survey for kochia and Russian thistle to see exactly what has happened to these populations since then. So unfortunately, we don't have the data for that yet. This graph is just showing the seeded acreage, and here I'm just focusing on Manitoba alone. And I pulled out the top 3 most grown crops in Manitoba. And you can see that canola and wheat acreage has essentially converged, and they're now competing for the most and second most grown crop. However, what I wanted to point out was the other line that kind of looks like an exponential increase, and that is soybean seeded acreage in Manitoba. So we're seeing these shorter and shorter season varieties being released, and we've seen a very large increase in adoption of growing soybean in Manitoba. And if this trend continues, actually next year, soybean might be competing for the most grown crop in Manitoba. So this does cause or create some issues as far as weed management, because now the 3 most grown crops in Manitoba, 2 of them are resistant to glyphosate. So in Manitoba, this is a picture that I took a couple summers ago, and actually much of my research in the past has focused on managing this problem. This is a picture of volunteer canola showing up in soybean, and even in the back there where it's pretty much solid yellow, those are flowers of volunteer canola. So I should almost be introducing this slide as soybean in a field of volunteer canola, really. So farmers are having quite a bit of difficulty managing volunteer canola in soybean with herbicides, and in Manitoba they've had to look at other non-chemical methods to try and compete with volunteer canola. So what I'm sort of getting at here, and this is a phrase that's shown up in a lot of the recent research coming out of Australia, we're looking at a new paradigm for weed control, where unfortunately, whether we like it or not, we are losing efficacy of many common, or many herbicide modes of action that we currently rely on. So in order to try and get a handle on this, researchers here in Western Canada have been looking at the cropping systems and different weed management tools that they've been using in other parts of the world. And we've looked to to Australia, where they're starting to implement weed control in a different part of the weed's life cycle. So this is harvest weed seed control. And the principle here is when we have weeds that mature in our crop, and when we harvest our crop, we also harvest those weed seeds, but those seeds are generally blown out the back of the combine. So when those weed seeds are blown out of the back of the combine, they enter the soil seed bank and are the source of emergence in subsequent years. So the idea is to try and manage those weed seeds so they don't enter the seed bank. And there are quite a few different options that they're adopting in Australia, and actually now 43% of Australian farmers are actually, or have adopted some form of harvest weed seed control. So one of the first methods here is narrow windrow burning. So you basically funnel the chaff and the straw into a narrow windrow and then burn that windrow to try and decrease seed viability. However, that could have, it's quite cheap and easy to use, but it could have potential environmental issues as far as burning is concerned. We also have narrow windrow rodding or chaff lining, where just the chaff is placed in a narrow row and it's just left in the field there. And the hope is that the chaff line essentially rots and decreases your weed seed viability. However, this could potentially have issues as far as emergence of crops in subsequent years. There's also chaff carts, which are an older technology that was originally invented here in Western Canada. And the whole idea here is just to funnel your chaff in some way into a cart, and the cart can be dumped in a pile and either burnt or grazed. There's the bale direct system, where the chaff and the straw out of the back of the combine are baled directly. The unfortunate downside to this is essentially removing all of the crop residue, so we don't really have a whole lot of carbon inputs back into our soil, and that could potentially have detrimental issues with decreasing soil organic matter. So one of the big things that I wanted to talk to you guys about was the Harrington seed destructor. So this is a newer technology that we've brought over from Australia, and we've actually been trying to get our own Harrington seed destructor here for about the last 3 years. And I'm happy to say that this past growing season we have been able to test this in the field. We don't have any field data from the Harrington seed destructor yet, but we do have some stationary data, which I'll get to in a second. So the principle for the Harrington seed destructor is it's essentially a mill that's pulled behind your combine, and the chaff, which is the yellow arrows, the straw, which is the yellow arrows, bypasses the mill, whereas the chaff is funneled into a cage mill. And the cage mill has discs that are rotating at high speeds in opposite directions, and it just grinds up the seed and essentially just mills it on the spot and spreads it back onto your field. So you have the same amount of residue that would normally be going onto your field. The same amount is going back onto the field. It's just all of the seeds are milled instead. So Brianne Tideman is a research scientist with Ag Canada from Lacombe, and she's had the opportunity to do some stationary testing, and this past summer she was also doing field testing of the Harrington seed destructor. So what they did for their stationary testing was they just took a bulk bag and dragged it behind the combine to collect all of the chaff coming out. They then funneled the chaff into the Harrington seed destructor and wanted to see how well the Harrington seed destructor would work to decrease viability of some of the common weeds that we have here in Western Canada. So this is an example of what you would see the chaff going into the seed destructor versus the chaff coming out of the seed destructor. And you can see it does quite a good job at breaking up the chaff as well as milling a lot of the seeds. So here's some data that we accumulated from the preliminary testing, or just the milling without taking it out into the field. And she essentially took these 3 different types of chaff and added a known number of weed seeds to it and fed it through the Harrington seed destructor. And you can see that there are some differences between species as far as differences like kochia had a greater amount of control in, say, false cleavers. But if I draw your attention to the y-axis there, you can see that the seed destructor essentially destroyed viability in greater than 98% of these seeds. And differences between chaff type, there were some differences, but again, greater than 98% of the seeds were destroyed. So this is looking like it's going to be actually a tool that we could implement here in Western Canada. The cost of this tool right now is sitting at about $200,000 for one, but they're also starting to integrate these tools into combines as well, and that is going to run around, or they're wanting to market that at about $80,000 to $100,000. So with that said, today I've talked about the increasing cases of herbicide resistance in Western Canada. Glyphosate resistance, even though we do not have, or we have 5 weeds that are resistant to glyphosate currently in Canada, but I do think that that's going to be increasing, especially in Western Canada, as we see shorter season glyphosate resistant soybean and corn varieties moving westward. There's also a limited number of herbicide modes of action. So herbicides, or new mode of action for herbicides hasn't really been released in the last 20 going on 30 years. And unfortunately, there's really no prospect for release in the near future. So really, what we have right now is kind of what we're stuck with. So we really need to look at adopting some of these other management strategies in order to preserve the efficacy of some of the herbicide modes of action that we currently have. And with that said, I'd like to first of all thank everyone that contributed research to this presentation, as well as thank the Weed Science Research Group at the Lethbridge Research Station, and some of the funding sources that contributed to the research that was presented here today. So if anyone has any questions, I'd be more than happy to try and answer them.
All right, there has to be some questions. I heard some groans when I heard the cost of the great new Harrington machine over here. So, all right, we've got a question at the back. Go ahead.
Yeah, so this report showed that while those were progressing, the Harrington seed destructor did a good job, but Dan's previous work did not show that most wild oats shell out before harvest when we put the Harrington seed destructor, correct?
Yes, this is correct. So unfortunately, one of the downsides to the seed destructor, it works well for the seed that enters into the combine and is expelled from the combine, but there are quite a few weed species that shatter their seed before we actually get around to harvesting. So unfortunately, even though the seed destructor looked effective at managing the seed that went into the combine, wild oats actually lose most of their seed before we harvest. So it's a beneficial tool, but it's not the complete solution.
Any other questions? You know, in the past, I think one of the big strategies has always been crop rotation as a way of managing resistance and rotating, crop rotation and herbicide rotation. Are those still thought of as effective, or are we losing the battle even in those techniques? Is resistance even resisting those approaches?
That's a great question, and I personally think that that crop rotation and herbicide rotation are, first of all, they go hand in hand. The greater diversity of crops that you have in your rotation, the greater diversity of herbicides you have to implement in your crop rotation. And I think that those are two very beneficial strategies that are they're used as part of a complete package for weed management. So we can't really rely on one strategy, but we should be implementing multiple strategies throughout the crop rotation.
And is there work being done kind of around the world too? Is there sort of a world approach to dealing with this? Because it's not just North American, isn't it? Is there some efforts going on worldwide to sort of tackle it and share research and sort of a collaborative approach?
Yeah, so there is, or a lot of the research actually in weed science is conducted throughout the world, right? So we have very close collaborations with weed scientists in multiple different countries, and I think we actually do work together quite well. So there's a lot of that collaboration going on, yes.
Okay, anything else? Just want to make sure I don't miss anyone. All right, with that, we'd like to say a big thank you to you, Kevin, for sharing this, and Charles, and we're very pleased that you could help us out with that. So, don't run away just yet.